What are the differences between numpy arrays and matrices? Which one should I use? What are the advantages and disadvantages of each? From what I've seen, either one can work as a replacement for the other if need be, so should I bother using both or should I stick to just one of them? Will the style of the program influence my choice? I am doing some machine learning using numpy, so there are indeed lots of matrices, but also lots of vectors, arrays.
As per the official documents, it's not anymore advisable to use matrix class since it will be removed in the future. This URL. As other answers already state that you can achieve all the operations with numpy arrays.
NumPy matrices are strictly two-dimensional, while NumPy arrays, arrays, are n-dimensional. Matrix objects are a subclass of an array, so they inherit all the attributes and methods of arrays. The main advantage of NumPy matrices is that they provide a convenient notation for matrix multiplication. If A and B are matrices, then a B is their matrix product. On the other hand, as of Python 3.5, NumPy supports infixed matrix multiplication using the operator, so you can achieve the same convenience of matrix multiplication with arrays in Python is greater than or equal to 3.5. Both matrix objects and arrays have .t to return the transpose, but matrix objects also have .h for the conjugate transpose, and .i for the inverse. In contrast, NumPy arrays consistently abide by the rule that operations are applied element-wise, except for the NuAdd operator. Thus, if A and B are NumPy arrays, then a B is the array formed by multiplying the components element-wise. To obtain the result of matrix multiplication, you use np ... or in Python is greater than or equal to 3.5, as shown above. The operator also behaves differently. Since A is a matrix, A2 returns the matrix product AA. Since C is an array, C2 returns an array with each component squared element-wise. There are other technical differences between matrix objects and arrays, having to do with np.ravel, item selection and sequence behavior. The main advantage of NumPy arrays is that they are more general than two-dimensional matrices. What happens when you want a three-dimensional array? Then you have to use an array, not a matrix object. Thus, learning to use matrix objects is more work. You have to learn matrix object operations and array operations. Writing a program that mixes both matrices and arrays makes your life difficult because you have to keep track of what type of object your variables are, lest multiplication returns something you don't expect. In contrast, if you stick solely with arrays, then you can do everything matrix objects can do, and more, except with slightly different function/notation. If you are willing to give up the visual appeal of NumPy matrix product notation, which can be achieved almost as elegantly with arrays in Python is greater than or equal to 3.5, then I think NumPy arrays are definitely the way to go. P.S. Of course, you really don't have to choose one at the expense of the other. Since np.asMatrix and np.asArray allow you to convert one to the other, as long as the array is two-dimensional. There's a synopsis of the differences between NumPy arrays versus NumPy matrices here.
SciPy.org recommends that you use arrays. Array or matrix? Which should I use? Short answer: use arrays. They support multidimensional array algebra that is supported in MATLAB. They are the standard vector/matrix/tensor type of numpy. Many numpy functions return arrays, not matrices. There is a clear distinction between element-wise operations and linear algebra operations. You can have standard vectors or row/column vectors if you like. Until Python 3.5, the only disadvantage of using the array type was that you had to use dot instead of to multiply, reduce, two tensors, scalar product, matrix vector multiplication, etc. Since at Python 3.5 you can use the matrix multiplication operator. Given the above, we intend to deprecate matrix eventually.
Just to add one case to Unyupu's list. One of the biggest practical differences for me of numpy and arrays compared to numpy matrices or matrix languages like MATLAB, is that the dimension is not preserved in reduce operations. Matrices are always 2D, while the mean of an array, for example, has one dimension less. For example, the mean rows of a matrix or array. With matrix, with array, I also think that mixing arrays and matrices gives rise to many happy debugging hours. However, SciPy.sparse matrices are always matrices in terms of operators like multiplication.
科学，